Yes, welcome students. This time we are giving you the solution of the integral dx upon 1 plus x4. This question was asked by one of my students, how to solve this integral. Of course, I can give you the two methods for this integral to solve. One, we go to the direct method. In direct method, we will use the concept of decomposition of an integrand into what is called partial fractions. That is one method. And second is we can make the suitable adjustment method, where we can write the numerator as the derivative of denominator, use f dash x by fx. When integral takes the form integral of f dash x by fx dx, then we can write it integral of the log of the denominator. Actually, there is one more method, third method. When we solve this integral over C, that is this over the set of complex this numbers. Here we are solving this integral over R. This is over R. R, you know, it is set of real numbers. How we go? Let us denote this integral I by integral of dx upon 1 plus x4. My integrand is now 1 upon 1 plus x4. I want to decompose this into partial fractions, and this solution is a bit longer one. And the second solution that I suggest to you, that is the adjustment solution, method of adjustment solution that I will give you. And with the help of that, you can solve many integrals, like you have integral of this type. What is integral of root tan theta d theta? What is integral of root cot theta d theta? You can do so many questions with the help of this. So when you are stuck at this, how to solve it, let us go by two methods. This is method number one. I am suggesting you, this is method first. Method first. Now I will take the denominator of this integrand. I will resolve this into partial fractions. Denominator is this. Denominator of integrand. Denominator of integrand, it is my x4 plus 1. I can factorize it, as you know how to factorize it, to express it in the form of a square minus b square, then write a plus b into a plus b, so that you can decompose the fourth degree into second degree. Then you see again, can we again convert this second degree into two linear factors over R. Let us see. I will write it. It is x4, x square whole square, x square whole square plus 1 square. I will add, this is a square plus b square. I will add here plus 2ab plus 2x square, then simultaneously subtract 2x square. I am adding and subtracting this 2x square and minus 2x square. Why so? This is just to write, it is missing here plus 2ab and minus 2ab. I am adding plus 2ab and minus 2ab when my a is x square and b is 1. Okay, now you connect this. This is your x square whole square plus 1 square plus 2x square minus 2x square. Look, this is your formula. Now you can write it is x square plus 1 whole square. That is x4 plus 1 plus 2x square. Then this I can write minus x root 2 whole square. I'm just trying to write it in the form of a square minus b square. This a square minus b square, which you know is a plus b into a minus b. Okay. Now as per this formula, this is your x square plus 1 plus x root 2, then x square plus 1 minus x root 2. So you have converted this into two quadratic factors. One is x square plus x root 2 plus 1, then x square plus 1 minus x root 2. Now the question is, can we resolve this integrand, this fraction, quadratic factor, or this quadratic factor into again two linear factors? Our set of real numbers, the possibility you can see, if your denominator becomes less than 0, you see, that is if your discrement is less than 0. If discrement is less than 0 of a quadratic fraction, then it is the proof that you cannot write it further into linear factors. You see there, my a is here 1, my b is root 2, and my c is 1. If I write d is equal to b square minus 4ac, that gives me d is equal to it is b square, this is 2, that is minus 4. It is minus 2, which is less than 0. So if I write the discrement of this quadratic, factor, or the discrement of this quadratic factor, that in both cases becomes less than 0. It means that we cannot resolve this quadratic factor or this quadratic factor into further linear factors over R, over the set of real numbers. No doubt you can write down the two more, this quadratic, this linear factors of this or that. It is only our this what is called the you can go our this C. So my integral is here. I can write I is integral of dx upon, this is x square plus x root 2 plus 1, then it is x square minus x root 2 plus 1. This way I have resolved this denominator, biquadratic denominator, into what? Linear factors. Now how we go? We shall now resolve this integral. Name this first for the time being, or we don't need to write first here. We go this way. We now resolve integrand. We now resolve integrand into partial fractions. How we go? It is 1 upon x square plus x root 2 plus 1 into x square minus x root 2 plus 1. Just wait a bit. I will drop that. There is an electricity problem. I will solve it. Well, we have to now resolve this integrand into partial fractions. This is a pure quadratic fraction. In partial fractions, you introduce two constants. With one constant, we write x like this. This is ax plus b upon x square plus x root 2 plus 1. It is quadratic rule for partial resolving this partial fractions. Then plus cx plus d upon x square minus x root 2 plus 1. Name this first. Now our aim is to find out the required constants a, capital B, capital C, and capital D. It is as per your partial fractions in previous classes you do. Okay. So what we do is we multiply both sides. Multiply both sides by LCM that we get here. It is x square plus x root 2 plus 1 into x square minus x root 2 plus 1. we multiply both sides by this, so we get 1 is equal to ax plus b times x square minus x root 2 plus 1. When we multiply by this and this gets cancelled, then plus cx plus d into x square plus x root 2 plus 1. Okay, let this be equation number 2. Now how we do it? Actually, in partial fractions, if you have a linear factor, you make that equal to 0, then we find out the a or b or c. You don't have here linear factor, so we simplify this. Let us simplify this. This is 1 is equal to, multiply with this, it is a, when we multiply with this, x cube minus x square root 2 plus x, then with b it will be plus b times x square minus x root 2 plus 1, then plus c x cube plus x square root 2 plus x plus d, it is x square plus x root 2 plus 1. Okay, we multiply this by this, ax into this, we get this thing, then b into this thing, it is this, then cx into this becomes x cube plus x square root 2 plus x, then d into this. Now we have to find out ABC. For that we compare the coefficients. Comparing coefficients on both sides. Okay, you see how we go. Okay, we write coefficient of x cube first. Compare coefficient of x cube. I compare coefficient of x square. I may need coefficient of x. Because we don't have linear factor here, we compare the coefficients. Our aim is to find out what is a, what is b, and what is c, what is d. Now look here, look at this setup. You don't have x cube on left side, so coefficient of x cube on left side is 0. You have here coefficient of x cube here. When you multiply with a, it is a, so it is a. Okay, then come here, coefficient of, where you have x cube, this is your x cube plus c. Okay, this is here your x cube is existing at this place, it is existing at this place, so coefficient of x cube here will be a. When you multiply with a, coefficient of x cube will be here c. Then coefficient of x square, you see what is coefficient of x square? You don't have coefficient of any x square term on the left, so coefficient there will be 0 is equal to. Now look here, coefficient of x square here, it is root 2 minus root 2, and this a will be minus a root 2. Then here you have coefficient of x square, that is b. Look here, you have coefficient of x square root 2, that is plus c root 2. C root 2. Which root 2? It is, this is this c and this root 2 when this c gets multiplied. And here you have plus d. Okay. Now from this setup I can write here a is minus c. A is minus c. I have got a minus c. I can use here a minus c here. This is 0 is equal to, when I use a minus c, this will be c root 2 plus b plus c root 2 plus d. What I did here, I replaced this a here, is a by minus c, this becomes plus c. Now this is 0 is equal to, this and this gets added, it is 2 root 2 c plus b plus d. Okay, now we have coefficient of x here. Look there, you don't have x term on left, this is 0 is equal to, let us see here, you have here x coefficient will be a, then you have here b also, coefficient of x, it is minus b root 2 here in this case. Coefficient of x is minus root 2, b gets multiplied, it is minus b root 2. Here coefficient of x, here is only one term x. When c gets multiplied with this, coefficient of x will be plus c. Then it is coefficient of x here d plus d root 2. Okay, let me see what happens. It is 0 is equal to, I will replace here a by minus c. It is minus c plus minus b root 2. This is plus c plus d root 2. Just look what is happening. This and this goes. It gives b root 2 is d root 2. That gives you b is d. This gives b is equal to d. Okay. Now I can use here, it is 0 is equal to 2 root c, 2 root 2c plus b is equal to d. Yes, it is b is equal to d here. It is b, when I use db as b plus b, this gives me 0 is equal to 2 root 2c plus 2b. Well, I have got coefficient of x cube, coefficient of x square, coefficient of x, where I have got b is equal to d. I may need also this to compare constant term. Also compare constant term. Let me write here. Comparing constant terms now. Constant terms. Comparing constant terms. Look here. Here you look. You have constant there on the left. It is 1 is equal to. Look here. No constant with a. Yes, you have a constant with b. It is plus b. You have a constant with c. No, you have constant. It is plus d. Plus d. That means you have b plus d is equal to 1. You have got b plus d is equal to 1. That is your b is here. You can get here. B is d 1 minus d. 1 minus d. Your b is 1 minus d. Your b is 1 minus d. Look here. This setup. When I use b is 1 minus d, it is your 1 minus d is equal to d. That is 1 is equal to 2d. d you have got 1 by 2. Now this has solved our problem. We can now get b. We can get now c. Now d is 1 by 2. Okay. D is 1 by 2. So when you have d 1 by 2, but b is equal to d, that means b is also implies b is also 1 by 2, because there b is equal to d. So b is 1 by 2, d is 1 by 2. Let us see what happens. 0 is equal to 2 root 2c plus 2 times, what is my b? B is 1 by 2. I can use 1 by 2. That gives me 0 is equal to 2 root 2c plus 1. This gives me 2 root 2c is minus 1. So c gives minus 1 by 2 root 2. Underline this. So here this implies, come here, this implies a is now, when I use it here, a is now 1 by 2 root 2. So all my constants are almost found. So this gives me c is minus 1 by 2 root 2. Yes, it is okay. D is 1 by 2 because b is equal to d. So b is also 1 by 2. And a is minus c. So I am using c there, minus 1 by 2 root 2. This gives a 1 by 2 root 2. Okay. In this way, I have got a 1 by 2 root 2. I have got b 1 by 2. I have got c. Minus 1 by 2. I have got d. It is my 1 by 2. I will use these all values in equation number first. Now we are reaching to this how this a, b, c, d gets replaced by their respective values. Then we will be in a position to integrate it now. Now using all these values, using a, b, c and d in equation number, yes, first use them in equation number first. I will be using this in equation number first. We have replaced these A, B, C and D by their respective values, and we come to this position. Okay, and this left hand side, this one, you know, it is the decomposition of the given integrand 1 by x4 plus 1 or 1 by 1 plus x4. So I can write this is our 1 by 1 plus x4 is equal to, here I can take 1 by 2 root common. Let me take 1 by 2 root 2 common. What is this? This will be x. You don't have here root 2, so this will be plus root 2. When you don't have it in the denominator, you can write it in the numerator. When you take it inside, you see it is x by 2 root 2, and this root 2 goes, it is 1 by 2. Then it is division by x square plus x root 2 plus 1. Here also you can go this way, take 1 minus, let's take minus 2 root 2 out. This will be x minus root 2 by x square minus x root 2 plus 1. Now we will be in a position to integrate this, because why? You have got the numerator factor linear, you have got denominator factor quadratic. Okay, this is linear, this is quadratic. So we have reached to the position that we can express this numerator as the derivative of denominator. Okay, this in that way we can use the integral of f dash x by fx dx, which is log of the denominator. Okay, let us go this way. This we could write in this way. Now I can write here integrate on both sides. We have just resolved the integrand. Now we can integrate it. Integrate. When we integrate, our integral becomes, let us name it I. Our integral is now I is equal to integral of, this is my I, or one setup I will write here. It is integral of dx upon 1 plus x4 is equal to integral 2 root 2 is a constant, I can take it out. It is integral of x plus root 2 dx, okay, by x square plus x root 2 plus 1. Then here also it is in fact 1 upon, it is 1 upon, sorry, it is 1 upon here. I'm sorry, here it is 1 upon, it is 1 upon 2 root 2. It is 1 upon 2 root 2. There also it is minus 1 upon 2 root 2 integral of x minus root 2 dx by x square minus x root 2 plus 1. Now if I differentiate this, this will be 2x plus root 2. 2x plus 2. I don't have 2x here. I don't have 2x here. That means I have to multiply by 2 here. So this is my given integral I. When I multiply here by 2, this will become 1 by 4 root 2 integral of, it is 2x plus 2 root 2 dx upon x square plus x root 2 plus 1. What I did, I multiplied by this 2 and simultaneously divide here by 2. This has become 4. If you take 2 again common, it will be this thing. Similar is the case here. This is minus 1 by 4 root 2 integral of, this is 2x minus 2 root 2 dx upon x square minus x root 2 plus 1. I have already told you this method is a bit lengthy one, and this is your first method where you use the concept of partial fractions. Now you see, if I differentiate this, what is derivative of x square plus x root 2 plus 1 with respect to x? It will be your 2x plus root 2. 2x plus root 2. So this means here I need root 2 and simultaneously I can subtract root 2. You see how I go. This is your 1 by 4 root 2 integral of, I need here 2x plus root 2. I will simultaneously subtract minus root 2, then plus 2 root 2 which is existing here. Okay, just write it dx upon x square plus x root 2 plus 1. Then in this case minus 1 by 4 root 2 integral of, here also I need 2x minus root 2. I will write here 2x minus root 2. Then I will use plus root 2. Then it is own constant minus 2 root 2. This is your dx by own factor x square minus x root 2 plus 1. You know, I have just added and subtracted this thing. This add and subtract. This is again this. I have also here added and subtracted this root 2, because when I differentiate x square minus x root 2 plus 1, this will be 2x minus root 2, which is this. So similarly here. Now this will transform into 4 integrals. One is 2x plus root 2 by this, which is f dash x by fx. Here plus root 2 minus root 2, that means root 2. I will take root 2 out. Here it is a minus root 2, that will be minus root 2, and this by this is again integral. We are reaching closer to the solution. Just see, I will make sure about this. Okay, you just look at this last setup. I have decomposed this integrand, this integral into 2. One is 2x plus root 2 by this, it is there. Then you have this 2 root 2 minus root 2, there is only root 2, it is there, and this goes inside, it is there, root 2 by 4 root 2, and this integral. Here also I took this separate. Why so? Because this is now derivative of this. This is the derivative of this. I have written as 2x minus root 2, it is there. Then this denominator, one integral, and second is this minus root 2 plus root 2, that becomes minus root 2. That becomes minus root 2 here. Minus root 2, of course, but when it goes inside, it is plus root 2 by 4 root 2. Look here. After this setup, you have this one. Now, this one is here. It is dx with respect to x, with respect to x, with respect to x, with respect to x. Now, I will be using this fact integral of f dash x by fx dx is natural logarithm log or ln of fx. Of course, plus c also, constant of integration, we don't mention it here. No need. This is your f dash by fx. When we differentiate this, it is 2x root 2. So this is now I is equal to 1 upon 4 root 2 log of denominator, that is x square plus x root 2 plus 1. It is this. Then here this plus 1 by 4 only integral of dx upon x square. I had already written dx here, sorry, it goes double, not a double one. X square plus x root 2 plus 1, then minus 1 by 4 root 2. Look here, it is f dash by fx. This is log of denominator also. X square minus x root 2 plus 1. Then this integral plus 1 by 4 integral of dx by x square minus x root 2 plus 1. Just look. Now what happens? I can take these two integral here. Take this and this. These values. Take 1 by 4 this out. It is I is equal to 1 upon 4 root 2 out. This will be your log x square plus x root 2 plus 1, then minus log x square minus x root 2 plus 1. Is it? Then we are left with these two integrals. This one, it is plus 1 by 4 integral of dx by x square plus x root 2 plus 1. Then this plus 1 by 4 integral of dx by x square minus x root 2 plus 1. Now it is log of m minus log of n. You can write it 1 by 4 root 2 log of m by n. This is x square plus x root 2 plus 1 by x square minus x root 2 plus 1. This is the simplified form of these two results. Log m minus log n is log of m by n. Now here we have to evaluate these two integrals. I will write it plus 1 by 4. I will name this integral I1 and name this integral plus I2. Okay. Now I have to find out what is I1 and I2 separately, then use it here. Let it be third equation. I will use it that then in third equation. I will find now them separately. We find I1, which is equal to integral of dx by x square plus x root 2 plus 1. I will use here the completing square method. You know how we complete the square. You look, it is x square plus x root 2 plus 1. You cannot find out it is linear factors, as you have seen that your d is here, discriminant is less than 0. When you complete the square, you do this way. It is x square plus x root 2. Then you add here what is coefficient of x here. The rule is that you must write coefficient of x square first 1 here when you write the complete square method in your integral calculus or in other this results. You have coefficient of x square already 1. That is our benefit. Here coefficient of x is root 2. I will add and subtract the half of it is square. That is, I will add root 2 is coefficient of x. It is half is 2 square. Simultaneously, I will subtract root 2 upon what? 2 square. And this one is here. Now, this is converted into formula. Which formula this is now? This will be x square, x plus, when you write this thing, it is root 2 by 2. Root 2 by 2 means 1 by root, or you can write it, it is plus root 2 by 2 square. Then minus root 2, it is 2 by 4 plus 1. Just to look here, this is a square, means this, b square, root 2 by 2 whole square is this, plus 2ab, that is 2x, 2 gets cancelled, it is x root 2. This is how to complete the square method. So this I am getting x plus 1 by root 2 square, okay, minus it is here 4, it is 2 by 4, is it? Minus 2 plus 4 is it is positive 2 by 4. Minus 2 plus 4 here, it is 4 minus 2, it is positive 2 by 4. This you can write now x plus 1 by root 2 square. This is plus only 1 by 2. Okay, I hope you are following me. Therefore, this means I can write this integral I1 now. Integral of dx upon, this is your x plus 1 by root 2 square, then this is plus 1 by 2. How we go now? Very interesting. This is my I1 is equal to integral of dx upon x plus 1 by root 2 square. I will write this also 1 by root 2 square. No problem. Why I am doing this? Because I know what is integral of dx by x square plus a square. This is a formula 1 by a tan inverse x by a. This standard result I am using. Okay. This is I is equal to, according to this, 1 by a, it is 1 upon 1 by root 2, because this is my 1 by root 2 here, 1 by tan inverse x. X is x plus 1 by root 2 upon 1 by root 2. Now just simplify this. Your I is, this goes up, root 2 tan inverse root 2 cancel. It is x root 2 plus 1 only. X root 2 s plus 1. This is my I1. This setup I need, this one setup. I will preserve this setup here. I may need that setup. I will preserve it. I will preserve it here. This I1 I preserve. My I is actually 1 by 4 root 2 log of x square plus x root 2 plus 1 by x square minus x root 2 plus 1. That then plus 1 by 4 I1 plus I2. This is my equation number 3 again. I need this. I need this. I1 I have found. Now I have to find out I2. Then my I2 is, what is I2 here? My I2 is here, this one. I2. dx by x square minus x root 2 plus 1. This is my I2. Just look. Wait a bit. Well, let us come. We will be now finding out what is this I2. I2 is our this. I can also write here completing the square method, just like previously. This is x square minus x root 2 plus 1. Look here. Coefficient of x is here root 2. Positive or negative doesn't matter, because we should have x square coefficient 1, that is there. It is x square minus x root 2. I will write the half of this, root 2 by 2, square it, minus root 2 by 2 whole square. I am adding and subtracting this, then plus 1. Now you see, this is your formula. Which formula? X minus root 2 by 2 square. And this is your minus 2 by 4 plus 1. This is a square, which is this minus 2ab, and it is this, b square is this. It is x minus 1 by root 2 square, then 4, it is again plus 2 by 4. That is x minus 1 by root 2 square plus this is 1 by 2, that is 1 by root 2 square. Therefore, I can write now I2 is integral of dx upon this one, x minus 1 by root 2 square, then plus 1 by root 2 whole square. I have simplified this because this is your 1 by 2, that is 1 by root 2 square. This is again the formula, the same formula we are getting when I is integral of dx by x square plus a square, the same formula, that is 1 by a tan inverse x by a. This is I2 is equal to 1 by a means 1 upon 1 by root 2 tan inverse x minus 1 by root 2 by 1 by root 2. This is I2 now. root 2, as we did previously, tan inverse x root 2 minus 1, because root 2 goes. This is my I2. I have found out I1, I have found out I2 using I1 and I2 in third equation. I will use I1 and I2 in equation number third. What is my third? It is given integral I is equal to 1 upon 4 root 2 log of x square plus x root 2 plus 1 upon x square minus x root 2 plus 1, then plus 1 by 4 out. 1 by 4 out. The value of I1 is there. There it is I1. Root 2 tan inverse x root 2 plus 1. This is value of I1. 1 by 4 is thrown out. It is thrown out. Then I2, use I2. But again plus root 2. Is it plus? Yes. Plus root 2. Plus root 2. Tan inverse x root 2 minus 1. Now we have to only simplify this. I can stop here. I can write this is the value. But as far as the question you have given me, this was the question given by one of my students. He is also giving there the answer of this. We may have to just change the this integral some way. This required result. I will see how we go. No problem. This is I is equal to 1 by 4 root 2. This is log of x square plus x root 2 plus 1 by x square minus x root 2 plus 1. Take root 2 out. This is plus root 2 by 4. Then this will be tan inverse x root 2 plus 1 plus tan inverse x root 2 minus 1. Look here. Now we can use the formula here. Tan inverse A plus tan inverse B is tan inverse A plus B by 1 minus AB. We can use this formula also. That is to convert this tan inverse in one tan inverse. It is a formula here. We'll be using it just. Okay, I have written this formula here. Tan inverse A minus plus tan inverse B. That will be tan inverse A plus B by 1 minus AB. We'll be using it here. Just look. It is I is equal to 1 upon 4 root 2. This is log of x square plus x root 2 plus 1 upon x square minus x root 2 plus 1. This is your root 2 by 4. This is plus. I can write it root 2 by 4 into root 2 by root 2. No problem. This is tan inverse A plus B means x root 2 plus 1 plus x root 2 minus 1 upon 1 minus x root 2 plus 1 into x root 2 minus 1. Just look there, that formula. Tan inverse A plus tan inverse B is tan inverse A plus B by 1 minus AB. I am using it here. Tan inverse A is this plus B is this upon 1 minus AB. Now you have to only simplify it. Simplify and look to the answer to that where from you have taken this question. Just look. This is your I is equal to 1 by 4 root 2 log of x square plus x root 2 plus 1 by x square minus x root 2 plus 1. Then you are rationalizing there. This is root 2 root 2 2. This is 2 plus 1 by 2 root 2. I have taken root 2 here, so that this is root 2, this gets cancelled, is 2 root 2. Now this is tan inverse. What? Plus minus goes, it is 2 root 2x upon 1 minus a plus b into a minus b. It is 2x square minus 1. It is 2x square minus 1. Just look. A plus b, a minus b, a square minus 1 square. It is this. This gives you 1 by 4 root 2 log of x square plus x root 2 plus 1 upon x square minus x root 2 plus 1, then plus 1 by 2 root 2. This is tan inverse 2 root 2x, then minus plus 1. It is 2 minus 2x square. This you can write further, 1 by 4 root 2 log of x square plus x root 2 plus 1 by x square minus x root 2 plus 1. This is your plus 1 by 2 root 2 tan inverse. 2 goes. It is root x root 2 by 1 minus x square. This is actually the result in complete form, but so far as your answer is concerned, it is here minus, and this is x square minus x root 2 in the numerator and denominator. We can do it. Log of m by n, you can write minus log of n by m. Use that formula. Just look. This is the result in complete form. That here also he writes in this one in the numerator, x square minus 1 by x root 2. We can do it because this is indefinite integral. I will just use 1 or 2 steps to clear your doubt, and then it will be the first solution. Second is the shortest one, but the result is the same. You will get the same result. I will also share that solution with you. Just wait, I am writing it in simplified form. Well, we have now solved the integral in a complete way. It is your, I will say, the complete solution it is, but there is a bit difference what your answer says. Don't worry. You see, I can write it, it is as per your answer I am going, minus 1 by 4 root 2. If you want to complete right hand side, minus 1 by 4 root 2, this will be log of x square minus x root 2 plus 1 by x square plus x root 2 plus 1. This is your plus 1 by 2 root 2 tan inverse x root 2 by 1 minus x square. Okay. It is this. You had there minus 1 by 4 root 2 x square minus x root 2 by this, not this by this. This is the, you can say, you can write log of m by n is equal to or simply, yes, is minus times log of m by n raised to power minus 1. This way also you can do, because this comes down, it is log of m by n, then it is minus log of n by m. I am using this result. Okay, so take numerator denominator change and you will get minus out. But here you have also a change, something change is there also. You see, you can write it minus 1 by 4 root 2 log of x square minus x root 2 plus 1 by x square plus x root 2 plus 1. I can write it now minus 1 by 2 root 2 tan inverse x root 2 by x square minus 1. I can do it. I have taken minus here common, because you remember that tan or inverse minus theta, you write also minus tan theta. No problem. Here in this theta, I have taken minus here. It was 1 minus x square. When you take minus here, it is x square minus 1. Where minus goes, it comes out. But this is not yet complete. Here you have this in the numerator, x square minus 1 by x root 2, as per your right hand side of the question. So how we go, you see. We can use the formula. How we express tan inverse A by B in terms of tan, again. I can write, let tan inverse A by B equal to theta. This means tan theta is A by B. This means cot theta is B by A. This again means tan of pi by 2 minus theta is B by A. This means pi by 2 minus theta is tan inverse B by A. So pi by 2 minus, what is this, theta, it is tan inverse A by B. So from I can say tan inverse B by A will be pi by 2 minus tan inverse A by B, or minus tan inverse B by A is tan inverse A by B minus pi by 2. Now you can pose a question. Where does this minus pi by 2 goes? It is getting merged with the constant of integration, arbitrarily constant of integration. You don't see in the answer that this minus pi by 2, because this is indefinite integral. This indefinite integral, you can write there c plus minus pi by 2 is again c. So you will not find minus pi by 2 on right hand side, because it is an indefinite integral. You can this add minus pi by 2 with the constant of integration. So according to this result, you can write this is now minus 1 by 4 root 2 log of x square minus x root 2 plus 1 by x square plus x root 2 plus 1. So what is this answer according to this? This minus goes merged. This is now plus 1 by 2 root 2. This is tan inverse x square minus 1 by x root 2. According to this is tan inverse B by A is tan inverse A by B, but plus or minus pi by 2. Pi by 2 I don't mention here, because this is indefinite integral. Pi by 2 gets merged with the constant of integration. This is now your complete answer. Thus you have proved. Thus integral of dx upon 1 plus x4, there is actually 1 upon 1 plus x4 dx, 1 upon 1 plus x4 dx is now 1 by 2 root 2, this first, tan inverse x square minus 1 by x root 2, x square minus 1 by x root 2. Then last with this minus 1 by 4 root 2 log of x square minus x root 2 plus 1 by x square plus x root 2 plus 1. This is what you asked me. How integral of 1 upon 1 plus x4 dx is equal to this thing. You could also write this way. No, you could stop here. But you want something this more. You want this integral. This is the first method that I have shared with you on the solution of integral. It is your as per your syllabus, that is use of partial fractions. But second method I will share soon, that will be the adjusted method. It is really more this easy, shortest than this, and result you will get same result, and you will use that method in other integrals, like integral of root tan theta, integral of root cot theta, integral of x square upon 1 plus x4, integral of x square 1 minus x square upon x4 plus 1. I will share likewise integrals like this 4 5 integrals on the basis of this fundamental result, a very important result. I have given a stress on this when you put this question to me, to how you solve this question. Thank you very much, and wait for the next solution, second method and second video. Till then, wait. I request you to make yourself strong logically and reasoning by reading this mathematics. Thank you very much. Okay.